Hello everybody and welcome to the second tutorial session on searching. So in this session we'll be taking a look at the second technique of searching, which is binary search. So in the previous video lecture I had talked about linear search technique, and I had discussed how it is considered to be a very inefficient technique because it has a time complexity of O(n), that is as it searches through the entire array in a linear manner, it progresses to the entire array in a linear manner. It ends up taking a lot of time, and the time complexity of this linear search method is O(n), which means that the longer the size of the array, longer it takes to search through the entire array for any particular number. So the second technique that we are about to explore here, which is called binary search, it has been designed to improve upon the shortcomings of linear search. So binary search is a lot more efficient technique, and this has a time complexity of O(n) by 2. So this means the time required to search through the entire array is essentially halved. Okay. So now let us take a look at the example of binary search. So once again I'll be referring to this article on binary search that is available at geeksforgeeks.com. So it says that given a sorted array of n elements, so the first thing that we need to keep in mind is that binary search can only be performed on a sorted array. Okay. So if we are taking an array that contains number in a random manner, in a random fashion, it will not work, it will simply fail. So before we can perform binary search on an array, we will have to check whether the array is sorted or not. If the array is sorted, we can go ahead and carry out the binary search, but if the array for some reason is unsorted, we'll have to sort it first using any kind of sorting technique like bubble or selection sort or any other sort for that matter. But it is not possible for us to carry out binary search in any array that is not sorted. So let us take a look at this example we have over here. So it says given a sorted array array of n elements, write a function to search for a given element x in ARR. So once again we have an array called ARR, and we will have to search for a number represented by x in this array. So a simple approach is to do linear search. The time complexity of this algorithm is O(n). So it means what essentially this O(n) means is the longer the size of the array, longer is the time that is required to search through the entire array. So the time complexity is directly proportional to the size of the array. So the size of the array is represented by this alphabet n. So the second approach is to perform the same task using binary search. So search a sorted array by repeatedly dividing the search interval in half. Begin with the interval covering the whole array. If the value of the array, so what we'll have to do is we'll have to take this first index and last index, and then we'll have to figure out the middle position of this array by dividing the first and last index by 2. So what it happens is it divides the array into two halves. So this one is the middle position, so 0 plus 9 by 2, it gives us 4. So 4 here is the middle position. So the elements before this index 4, this contains the numbers that are lesser than 16, and the elements, as this is a sorted array, we can say that the elements that exist before this index 4, that is in indices 3, 2, 1 and 0, this will contain numbers that are lesser than 16, and the elements that follow this index 4, that is 5, 6, 7, 8 and 9, this will contain numbers that are bigger than 4. So if we had to search for any particular number, so we can just compare the value of that number to that of the middle value. So out of this there are three possibilities which can happen in this situation. So either the number that we want to search, that will be an exact match with the value that exists in the middle. So say if we wanted to search for the number 16, so what we'll do is we will take that number, say x, and we'll compare it with the value that exists in the middle position of the array, that is 16. So 16 here and the 16 in the value x, it will be an exact match. So we will simply say that the number was found at position 4, and it will terminate the program. But the second possibility is that the number that we want to search is bigger than 16. So as this is a binary search, and as this array is already sorted, we can say that the number that is bigger than 16, it will only exist in this second half of the array, in the right hand side. So say we want to search for the number 50 or 56. So 56 here can only exist between 16 and 91. So what we'll do here is we'll focus our efforts of searching in the second half of the array. So there is no need to search to the entire length of the array. We know that it is a sorted array, and therefore if we want to search for a number that is greater than the number that is present in the middle, we'll have to focus our efforts in the second half of the array, that is in the right hand side. So if we are to search for the number 56 or any other number that is bigger than 16, we'll have to keep our search space confined between 91 and 23. So in that case, what we'll do is initially the lower bound was taken as 0 and the upper bound was 9. So the upper bound will remain at the 9th position, but the lower bound will be shifted from 0 to one value, one position, that is adjacent of mid. Sorry. So if the initial middle position was at 4, so the new lower bound will start from the middle value plus 1, that is the value adjacent to the middle position. So from here, from the number 5, so the lower boundary of this array will be shifted from 0 to 5. So now we'll be able to search from 5 to 9, and if the number that is being searched is bigger than 16, then it will either exist in this portion of the array, or it will not exist at all. Say we wanted to search for the number 100. So as this is a sorted array, this number 100 is either going to exist between 5 and 9, or it will not exist at all. So this is the second possibility, and the third possibility obviously is that the number that we wanted to search would exist between this 12 and 2, that is in the first half of the array. So if we wanted to search for a number that is lower than 16, say 5, so obviously in a sorted array it would exist between 2 and 16. So in that case, what we can do is we can reduce the searching space by half. So the amount of time it will take to search through this part of the array will be lower than searching through the entire array. So instead of searching through the entire array, we'll be reducing our searching position between this index 0 and index 3. So in that case, we'll be keeping the lower bound at 0, and we'll be deducting the position of the upper bound to mid minus 1. So if the value of mid is 4, the upper bound will become mid minus 1, that is 3. So if we wanted to search for a number that is lower than 16, so it will either exist in this half, or it will not exist at all, because all the numbers that are lower than 16 in a sorted array is bound to exist in the previous half, that is in the first half. So like this it will continue as long as we are not able to find the number in the array. So it will continue, the search procedure will continue as long as the value of the lower bound is less than that of the upper bound. So there are two bounds, the lower bound which represents the first position of the array, and the upper bound which represents the last position of the array. So this is, in some programs this is known as lower and this is called upper, and in other programs or algorithms this starting point is known as the lower bound, and the ending point is called the upper bound. So in order to calculate mid, we'll have to take the values of the lower bound and upper bound, and we'll have to calculate the mid position by dividing the sum of lower and upper by 2. So we'll continue adding the lower and upper bounds in each iteration of the loop, in each iteration of the while loop that we'll be employing to perform the binary search, and it will continue as long as we are not successful in finding the number that we want to locate in the array. So if at any stage the value of lower becomes greater than that of the upper bound, then we can conclude that we have searched through the entire array and we have not been able to find the number in question. So if the number that we wanted to find is located at any point in the array, it will simply terminate, it will simply print that the number was found at this location. It will exit the loop by using a break statement. So this this lower bound will not get an opportunity to rise in value above the upper bound. So it can only happen if the while loop is able to traverse the entire length of the array, and in that, under those circumstances, the value of the lower bound will become, eventually it will become greater than the upper bound. And when that happens, we can, like I said before, we can conclude that we have searched through the entire array but we could not find the number, and so we will just print that the number was not found. And lastly, it says that the idea of binary search is to use the information that the array is sorted and reduce the time complexity to O log n. So now let us go through the program code. So here we have the code for binary search. So here we have taken some variables. C is obviously the loop counter, first for the upper bound, last for the lower bound, first for the lower bound and last for the upper bound. Middle for the mid position, n indicates the number of elements present in the array. Search to store the number that we want to search in the array and the array itself lastly. So enter the number of elements that we want to include. We have taken in the first few lines. So we have taken the total number of elements that we want to input in the array, and it is represented by n. So the capacity of the array, like in the previous program on linear search, the capacity of the array is 100, but it is too time consuming to take 100 numbers, so the amount of numbers will be entering in the array at any given time will be represented by n. So after we have accepted all the numbers in the array, we are going to accept the number that we wanted to search. So this value that we want to search in the array, it is stored in the variable called search, and then we are assigning 0, that is the lower bound, to first, and the upper bound, that is n minus 1, to last, and the middle value is the sum of first and last divided by 2. So as long as the value of first is less than equal to last, this is the condition of the while loop that is used to perform the binary search. And here we are assuming that there is one thing that hasn't been mentioned in the program. So while entering numbers in this array, we'll have to make sure that the numbers are entered either in ascending order or in descending order. So let me give a comment over here. So the numbers are to be entered in sorted order only. As we are not performing any kind of additional sorting in this program, we'll have to, it will be the duty of the user to enter numbers in a sorted manner while giving them for the array. So either we can enter the numbers in ascending order or descending order, but they must be in a particular order. You cannot enter numbers in an arbitrary manner in this array, because if you do that, the binary search technique will not work. So first of all, it sees whether inside the for loop, in the while loop, it says whether the value of the middle, the value that exists in the middle, it is less than search, that is the number to be searched, or not. The value that exists in the middle position of the array, whether it is less than the number being searched or not. If that happens, what we are doing is we are deducting, we are adding one a value. We are taking the value of first, that is the upper bound, the lower bound, and we are adding 1 to it. So what we are doing is we are taking the middle position and we are adding it by incrementing it by 1. And if the value that we wanted to search was an exact match with the number that is present in the middle of the array, so we are just simply printing that the value was found at this location. And if the number that is being searched is lower than the value that is present in the middle position, so like I discussed in this previous example, so if we wanted to find a value that is lower than that of this middle position, so we'll have to confine our efforts of searching between this 2 and 12. So in that case, the lower bound will obviously stay at this L, but the upper bound, which was initially at 9, it will be reduced to middle minus 1, so it will go back to 3. So then the lower and upper bound will be between 0 and 3 respectively. So it will enable us to save time that is required for searching. So, and after exiting from the while loop, we'll check whether the value of first is greater than that of last or not. If the value of first is found to be greater than last, we'll say then the number was not found in the list. So now let us run the program and check the output, and like in the previous example, I'll be dealing with 5 or 6 numbers only. So I am entering some numbers in sorted order 1, 4, 5, 8, 10. So the number that I want to find is say 4. So 4 found at location 2. So this one's correct. So let me run the program once again, and this time I'll be giving some sorry, let me rerun this. So let me take 5 numbers and I'll be giving them in say descending order 5 sorry 4 3 2 and 1. So let us look for a value in this array 78. It says 78 wasn't found in the list because obviously 78 doesn't exist in this array. So this is the whole process of binary search, and it is considered to be more efficient than linear search because the amount of time that is required for searching is reduced by half in each iteration, and we are not forced to search through the entire array because every time we are calculating the middle position, which is the sum of first and last by divided by 2. So this is essentially halving the search space that we'll have to traverse while locating a number in the array. So this method is a lot more efficient as compared to linear search. So this concludes our tutorial on binary search. If you have any queries, please leave them in the comment section, and I'll see you in my next video. So have a nice day and take care, guys.